Okay, so in this detail we can see a detail in the corners on the roof, on the ceiling, and on the floor. The process would be to put some neoprene bands both on the floor and on the ceiling. First of all, one of the important things obviously is clean. We'll talk about this later on, but the making sure that external wall, that existing wall, is totally free from protruding elements, making sure that it's a smooth surface. We then fix a cupurized timber element on the ceiling. This provides extra rigidity for the plasterboard structure. Also achieves a thermal buffer zone in those corners, which is quite often a problem. The VIPs are then adhered to the existing wall. On top of that, VIP, and one of the things mentioned before, and then the VIPs can be obviously they're modular. We have to do the modulating before the work on site. So all the panels need to be fabricated in the factory and brought on site, ready to mount. It's not so much the cost of the special pieces; it's the case that we cannot cut on site. Obviously, any perforation, the cutting is impossible. This is one of the disadvantages compared to traditional installations. So we need to design all the modules precisely before we go on site. But as always, in the reality, there's always those small areas which can't be covered. So in those small areas, obviously the pier will be used to make up to bridge those gaps around windows, for example. The vapor barriers then adhere to the VIPs. We then place the aluminium channels both on the ground slab and on the ceiling, and mount the plasterboard structure. At this point, we fix the OSB after putting the mineral wool insulation. We fix the OSB to the structure, and at this point, we need to put the pier on the ground, the horizontal planes, the horizontal VIPs on the floor and the ceiling, and then we proceed with the floor coverings, the plasterboard. So, some of the considerations: we need to make sure that the walls are free of damp before installing the VIPs. We need to remove any protruding elements, as we mentioned before. All the suspended ceilings, the existing floor needs to be removed up to 1 meter within the building. The surfaces need to be predetermined and removed from the existing wall, and the new surfaces need to be planned into that buffer zone. Obviously the VIP models will need to be adjusted beforehand, and we need to make sure where we're going to use pier where needed. The maximum floor to height ceiling needs to be determined beforehand. Obviously, as I mentioned before, depending on the ceiling height that we have in the room, we need to adjust the aluminium studs. Also, we need to look at any heavy elements that need to be hung from the wall. So if we're in a room where sanitary use elements need to be hung from the wall, we need to make sure that the buffer zone, the aluminium structure has reinforcement, so they'll be able to take the weight of these elements. As we mentioned before, was in areas around the windows, pier will be used, so we can cut the pier exactly to the areas needed in those areas. Other installation tips: the VIPs will arrive in containers, specially packed containers, with all the pieces, with the dimension pieces in each one. the idea would be, what we looked at was that each container there'd be a container for each room to be retrofitted. So there's no actual handling of the panels on site by the people who are mounting them. Each package will have the handling instructions and warnings. It's important to ensure that the panels are firmly fixed to the existing wall to make sure there's no gaps behind them that could create moisture problems. In the vapour barrier, another important point is that if the existing wall already has a vapour barrier within its system, that needs to be removed, or we need to at least make sure there's no moisture within that final layer. Otherwise, we might trap moisture between the two vapour layers. All of the edges of the vapour barrier need to be well sealed to ensure airtightness. The exterior wall protection. Obviously, another really important point is that if we're highly insulating the internal facade in a building which beforehand didn't have any insulation, then that external wall is going to be a lot colder than beforehand, and this could cause problems, especially in materials which are absorbent, that absorb rainwater, for example, in brickwork and concrete. So it's advisable to treat those external surfaces with some sort of sealant, a rain-repellent sealant. Otherwise, we could get problems with freezing water within that barrier. The aligning independence is important that the plasterboard structure is independent from the VIP, so there's no pressure on the panels. And it's important that there's insulation continuity around windows and other openings. The cubic feedback, similar to the external testing, there's no vacuum loss was detected on the reception or during the time that they were mounted. There was a small displacement again with the rubber layer, and that's been resolved now with more adhesive between the rubber and the VIPs. The targeted thermal transmittance, which was 0.015, was achieved according to the measurements carried out. And regarding the hydrothermal performance, there's no relative humidity higher than 80%. However, this was tested between July and October, so the testing has gone on, and we're looking at if there are any further problems. And finally, when the installation didn't seem to be too complicated, as long as the procedures are followed carefully. Just to finish up now, and obviously the overall evaluation of the building of the system is that we achieved the projected energy savings. We occupy the minimal area possible, and at the same time the system resolves all the identified key requirements. And that's all.